In this tutorial, we're going to take a look at 4 examples of solving problems using systems equations. In all 4 of these examples, it's going to be a word problem, and you have to make up the system of equations, the 2 equations, and I'll talk and discuss how you do that as we go through the 4 examples. I'm going to also solve each of these by substitution and elimination, so you get to see both methods as well, and we'll check all 4 of them also. So the first one, we're told that John has 79 coins and just dimes and quarters in his piggy bank, and that altogether he has $13 in these dimes and quarters. So you're asked, how many of each coin does he have? The first thing you should do in any question, system of equations question, is define what your variables are. You're making up the equations, so whatever variables you use, you have to write out what exactly they mean, what they represent. So it says here in this sentence, how many of each coin does John have? So the variables represent the number of dimes and quarters in his piggy bank. So I'm going to use D to represent the number of dimes and Q the number of quarters. You don't always have to use X and Y. Use variables that have meaning to your question. And be specific in your let statement. Don't say let D be dimes and Q be quarters, because that's not, well, what does it mean? If D is dimes, is D the value of a dime? Okay, it's supposed to be how many dimes there are. Okay, so be very specific in your let statements. So this first sentence says he has 79 dimes and quarters altogether. So the way we write that mathematically is D plus Q equals 79. D represents how many dimes he has, Q is how many quarters he has, so together the two have to add to 79. And often in these questions, not every single time, but a lot of the time, probably like 75 or 80% of the time, there's a total amount equation, and then there's another equation that has to do with percentages or rates or values. Okay, so that's often true. Okay, not all the time, but a lot of the time. So that's I call it the total value equation. Now the second one has to do with the value. $13, he has $13 altogether in dimes and quarters. So the value of dimes, a dime is worth 10 cents. So let's say I had 17 dimes. If I multiply the 10 cents by 17, then that tells me I have $1.70 in dimes if I had 17 dimes. So the 0.10 is the value of each one. If we multiply that by how many there are, we get the value of those dimes. So I'm going to start off with multiplying 0.10 times D, because D is how many dimes I have. So that's the value of the dimes. And I'll do the same thing with the quarters, but of course they're worth 25 cents each, or $0.25. And together the value of the dimes plus the value of the quarters should add to $13, because we're told he has $13 in dimes and quarters. So this has to do with the number of coins he has altogether. This has to do with the value of the coins. Okay, so 2 different equations, but those are our 2 equations. So I'm going to solve these. I'm going to do substitution first for all these. So the first equation is probably the easiest one to isolate, and D or Q, it wouldn't matter. Okay, you could easily solve for D or Q because they have coefficients of 1. So I'm going to isolate for D here. The Q is added to the D, so I would subtract Q from both sides. So this is my substitution solution here. So I'm going to take away Q from both sides. So that adds to 0 or subtracts to 0. So D would equal to 79 minus Q. So now we write down the second equation, and we're going to substitute that, because that's what D equals. That's what D equals. We're going to substitute that in place of D right there. So I'm going to rewrite the second equation now with the 0.10, but in place of the D, I'm putting the 79 minus Q, because that's what D is equal to, plus the 0.25 Q equals 13. And now I have an equation that just has Q's, so I can solve for Q. I can isolate Q. But before I can do that, I need to distribute this 0.10 into the brackets. So 0.10 times 79 is 7.9, and 0.10 times negative Q is negative 0.10 Q, plus the 0.25 Q equals 13. So let's do some collecting like terms. These 2 Q terms are like terms, so 0.25 Q minus 0.10 Q would be 0.15 Q. That's added to the 7.9 to equal the 13. Now I want to isolate the Q terms, so I want to get rid of this 7.9. It's added to the 0.15Q, so I will subtract 7.9 from both sides. So that's gone because that's 0 right there. So 0.15Q is equal to, and that subtracts to 5.1. The reason I put the second 0 is because it's money actually, so that's why, if you want to write 5.1, that's fine. Now I want to isolate for Q here, so I have the 0.15Q term alone, so I wanted to get rid of that 0.15. It's multiplied by the Q, so we would divide out the 0.15, and we get Q to be 34. So that tells me that there should be 34 quarters, because Q is number of quarters, in his piggy bank. So now we need to find the number of dimes. And the red equation is probably the most convenient one to use. The second one will work, but it's a little bit more work. So we're going to put 34 and place a Q. And so to solve for D, the 34 is added to the D. So I would subtract 34 from both sides. So D would equal 79 minus 34 is 45. So it looks like he has 45 dimes. Now, so if you want to solve by elimination, so I'm going to call this equation 1 and this equation 2. And I'm going to eliminate the D. You could just as easily eliminate the Q. To do the D, I want to multiply by a number to make that term the same as this one. So I would multiply by 0.10 to get 0.10 D at the beginning of this one. So first equation is going to be multiplied by 0.10. So 0.10 times D would be 0.10 D. Plus 0.10 times Q would be 0.10 Q. And then we also multiply the 79 by the same number, 0.10, and that's why there's a 7.9 in the end here. Second equation can be written down exactly the same because it already has a 0.10 D at the beginning. Now the D terms are the same, so if they're the same, we subtract to eliminate that term. So no D's because those two subtract to 0. 0.10Q minus 0.25Q would be negative 0.15Q, and 7.9 minus 13 is negative 5.1. Notice this is almost exactly the same as what we had over here, just opposite signs, but it doesn't matter, we're still going to get a positive 34. We would divide out negative 0.15 from both sides to isolate the Q, so Q still works out to be exactly 34. So if I was doing elimination, I now have Q, I need to find D, and then after this we do exactly the same thing again. Okay, to find D, we could put 34 in place of Q in this equation and find that D is 45. So that part would be exactly the same here. So we don't really need to do that exactly the same thing again. So it looks like John has 45 dimes and 34 quarters. So let's do the check now. In the original equation, so D plus Q is what's on the left side here. D is 45 and Q is 34, so 45 and 34 add to 79, and that's what's equal to the right side, so that's good. That check actually tells us that John has 79 coins. This one here has to do with the value, so to make sure it adds up to $13. So in place of D here, we'll put the 45. And in place of Q, we'll put the 34. So if you multiply 0.10 times 45, that's 450, so he has 450 in dimes. And 0.25 times 34 quarters is 850 in quarters. So that actually tells us he has $4.50 in dimes and 850 in quarters. And if you add those two numbers together, that does add up to 13, which is what's on the right side. So it checks. So which means he has $13 in coins. So that's the checks, just to make sure that the solution is correct. Second example, in this one we have an aluminum alloy. We have one alloy that's 30% aluminum and another one that's 60% aluminum. So we're going to mix them. So this is they often call them mixture problems. So we're asked how much of each to the nearest gram should be mixed to produce 400 grams of a 50% aluminum alloy. Okay, so in the final product we're going to mix some of this and some of this to get exactly 400 grams that is 50% aluminum. Then again, solve the system of using a system of equations. So when in the second sentence is how much of each should be mixed. Each is the 30% part and the 60% part. So our let statement should, and I'm going to use X and Y here because we don't really have words like dimes and quarters. So I'm going to let X represent the amount of 30% aluminum to mix, and Y represent the amount of 60% aluminum to mix. And now you're doing this as some kind of a fabrication where you'd be melting it down so it's not like it's solid, probably. Okay, so you're probably actually melting it down to mix it to make this final product. So X is the amount of grams of 30%, and Y is the amount of grams of the 60% aluminum. Now, just like the last example, one equation, and there's this total amount, is the two amounts that we're adding together has to add to 400 grams. We couldn't, for example, take 100 grams of this and 150 grams of this and add them together and expect to get 400. The two numbers that we're adding have to equal 400. Okay, so you have to have 400 in your final product. So that's the total amount equation like I was talking about previously. Now notice we haven't talked about the percentages at all yet. So that's what the second equation is about. Very similar to the values of the coins in the first example. So the amount of aluminum in the final product comes from some aluminum from this one and some aluminum from this one. Okay, so if we multiply, so X is the number of grams of the 30% aluminum part that we're mixing. So if we multiply the number of grams of that by 0.30, that's the 30%, then that's the amount of aluminum coming from that 30% aluminum alloy. And we're going to add to that, and the second part we're mixing is 60% aluminum. So if we multiply by 0.60, that's the 60%, times the number of grams we're mixing from the 60% aluminum, then altogether that has to equal the amount of aluminum in our final product. Well, the final product is 400 grams and it's 50% aluminum. So if we take the 400 grams and multiply by 0.50, then, well, it's half aluminum. That's what 50% aluminum alloy would mean. It's half aluminum and half something else. Okay, you don't have to worry about what that something else is. So this would equal 200. So basically, this is the amount of aluminum coming from the 30% alloy. This is the amount of aluminum coming from the 60% part. And altogether, it has to add to 200 because that's 50% of the 400. So that's the two equations. So let's solve by substitution first. And if I'm doing substitution, this first one is the easier one to isolate for X or Y because there's coefficients of 1 for both of them. I'm going to choose X here. So I'm going to isolate for X. So I want to get rid of the Y. So the Y is added to the X. So we would subtract Y from both sides. So that adds to 0. So X would equal 400 minus Y. So now I'm going to rewrite I'm going to write my second equation, and I'm going to substitute. This is what X equals. That is going to go here in place of X. So we would rewrite this equation now with 0.30, and in place of X, we'll put the 400 minus Y plus the 0.60 Y equals the 200. And now I have an equation that just has Y, so I can solve for Y. So I want to distribute the 0.30 in here first. So if we multiply 0.30 by 400, 30 times 400, then that's going to be 120 at the beginning. So it'll be 120. 0.30 times negative y is negative 0.30y plus the 0.60y equals 200. So let's do some collecting like terms. These two terms would add to 0.30y. Basically, it's 0.6 minus 0.3 and then a y at the end, plus the 120 equals 200. I'm trying to solve for y, so I want to isolate this 0.30y term. So I want to get rid of the plus 120. So the opposite of adding 120 would be to subtract 120 from both sides. So that's 0, that's gone. So 0.30y would equal, and this would subtract to 80. So I want to solve for y. The 0.30 is multiplied by the y, so we would divide by 0.30 on both sides. And 80 divided by 0.30 is, well, I'm going to bring the calculator back here. It's not exact. It says to the nearest gram. Okay, so there is a repeating decimal here. If I divide 80 by 0.30, it's actually 266.6 repeating. So I'm rounding to the nearest gram. That would round to 267. So now that I have y, I want to find x. So let's find x. The rate equation is probably the easier one to use. So we'll take the 267 and put it in y, in place of y here. And so I want to solve for x, so the x has 267 added to it. So we'll subtract 267 from both sides to isolate for x. So this is gone, and 400 minus 267 is 133. So that's the solution by substitution. So if you want to instead use elimination, so again, let's call these equations 1 and 2 over here. And you could eliminate y or x. It would be your choice. I'm going to do x here. I want to have the same x term at the beginning of this one as I have at the beginning of this one. So I'm going to multiply that by 0.30, and then I'll have a 0.30x at the beginning of both of them. So first equation gets multiplied by 0.30, so 0.30 times x is 0.30x plus 0.30 times y is 0.30y. And maybe we'll bring the calculator back here one more time. 400 times 0.30 works out to 120. So that's why there's a 120 on the right side. And then I can write my second equation right below it. The x terms are the same sign, so we would subtract, just like we did in the first example. 0.30y minus 0.60y would be negative 0.30y, and 120 minus 200 is negative 80. Again, very similar to what we have over here, just the signs reversed. So we would divide out the negative 0.30, and we get y to be 267, just like we did down here. So now that I have 267, I would want to find x, and just like in example 1, this part would be the same. We would substitute 267 in here and find that x is 133, just like we did for the substitution. So it looks like, and remember, x is the number of grams of 30% aluminum. So it looks like there's 133 grams of the 30% alloy that should be mixed, and 267 of the 60% one. So let's do the check. In the first equation, x plus y is the left part of the statement. Remember, ls is left side. So x plus y, we're going to put 133 here and 267 here. And if you add 133 and 267, you get 400. Okay, so that's what you're supposed to. See, the two amounts have to add to 400 because we're making 400 grams of this 50% aluminum alloy. So it checks in the first equation. So in the second one, 0.30x plus 0.60y. So again, 133 here and 267 here. And I want to actually do this one. Actually, 0.30 times 133 is 39.9, and 0.60 times 267. And if we add those, plus 160.2, now we get 200.1. I'm going to put this, and I'll bring that back. The only reason, you see, it's supposed to equal 200. The only reason it's slightly different is because we rounded. Remember, it was 266.6 repeating, and the exact amount here, this is actually 133.3 repeating. So it doesn't exactly equal to 200, but it's close enough. So since the left and right sides are equal or extremely close to being equal, the solution is to mix 133 grams of the 30% alloy and 267 grams of the 60% alloy. Example number 3. Evelyn has $1,200 in her bank accounts. Some of it's invested in a savings account that at 1.2% interest rate, and the rest is in a tax-free savings account, often called a TFSA, tax-free savings account, that earns 3% interest. And we're told in a year she earns $26.10 in interest between the two accounts. So we're asked how much does she have in each account? And again, solved by using a system of equations. So this sentence here is what helps us write our let statements. How much is in each account? So this is what I could write for my let statements. I'm going to let S represent the amount of money invested in the savings account at 1.2% interest, and T represent the amount of money invested in the tax-free savings account at 3% interest. So S and T represent the amount in the savings account and the tax-free savings account. So there's a total amount equation, just like there were in the first two examples. The two amounts of money together have to add to $1,200 because this first sentence says Evelyn has $1,200 in bank accounts. So that sentence in mathematical terms, it says is S plus T equals 1,200. That says the same thing as Evelyn has $1,200 in her bank accounts. So the two amounts have to add to 1,200. So that's the total amount equation. The other one has to do with the rates, the two interest rates and the amount of interest she earns in a year. So we need this formula. The way you calculate interest is you multiply your principal by your rate by the time. The time in years, as long as the interest rate is quoted per year. So for the savings account, S is the number of dollars in the savings account. And we will multiply that by, now we need to write this 1.2% as a decimal. So it'll be 0.012. And it says in a year, so the time would be 1 year. So if we multiply S by 0.012 by times 1, well, that's 0.012S. And similar for the tax-free one, T is the amount of dollars in a tax-free savings account. Its interest rate is 3%, so we'd multiply by 0.03, and again, times 1 year, and that works out to 0.03T. So this is the amount of interest she earns from the savings account. This is the amount of interest she earns from the tax-free savings account, and together we're told they have to add to $26.10. So that's where my second equation comes from. Let's get rid of my writings. So that's my two equations. So I'm going to, again, solve by substitution first. And the first equation is the easier one to solve for S or T. I'm going to do S. So, but you could do T if you wanted. It would not matter. So to isolate S, the T is added to it. So I would take away T from both sides. So that's 0 right there. So S would equal 1,200 minus T. So let's write the second equation. And then just like before, this is what S equals. So that's going to go in place of S right there. So we'll rewrite the second equation, and 1,200 minus T substituted in place of the S, plus the 0.03T equals 26.10. And I have an equation with just T, so I want to isolate the T. First, I have to distribute this 0.012 into the brackets. So 0.012 times 1,200 is 14.4. 0.012 times negative T is negative 0.012T. Plus 0.03T equals 26.10. Let's collect some like terms. These two terms here are both T terms, so they would add to 0.018T plus the 1440 equals the 2610. So I'm trying to solve for T, so I want to get rid of this 1440. I want to isolate the T term. So the 1440 is added to this. So we would take away 1440 from both sides. So that's 0 right there. So 0.018T on the left, and this subtracts to 11.7. And then we would divide out the 0.018. And we get T to be 650. So that means in the tax-free savings account, remember that's what T represents, that she should have $650. So now we want to find S. So I'm going to use the first equation here. We're going to write that one down. And we're going to put 650 in place of T. So I want to solve for S. So the 650 is added to the S. So we would take away 650 from both sides. So that's gone. So 1,200 minus 650 is 550. So it looks like Evelyn has 550 in her savings account, the regular savings account. Now, if you want to instead solve by, so that's my solution, solve by elimination. So I'm going to call this equation 1 and this equation 2. And I'm going to eliminate the S term. So I want to get the same S term at the beginning of this one as I have at this one. So I'm going to multiply this equation by 0.012, and then I'll have a 0.012S here. So equation 1 times 0.012, so 0.012 times S would be 0.012S. Plus 0.012 times T would be 0.012T. And if I take 1,200 and multiply also by 0.012, I do get 14.4. Second equation does not need to be multiplied by anything at all. And we'll put a line underneath here. And so these are the same. So we would subtract. Remember I said there's one we're going to add. So you might guess that's the last example, number 4. So these are going to subtract to 0. .012t minus .03t is negative .018t, and 14.4 minus 26.1 is negative 11.7. And again, just same as what's here, just different signs. So let's divide out the negative .018. And we get t to be 650. So same as the last one. If we had started by elimination, so I got 650, I would now want to find s. So then we would do this to find s if you were doing just the elimination. So here's the check. So left side is, in the first equation, is s plus t. So we're going to put 550 for s and 650 for t. That's what we think our solution is. And those two amounts do add to $1,200, so that means she does have $1,200 invested between the two types of accounts. Second equation is the amount of interest check, basically. So that's the left side right there. So we're going to put, again, 550 for s and 650 for t. And if we multiply these, 0.012 times 550 is 660. And 0.03 times 650 is 1950. So this is actually telling us that she has earned $6.60 from the savings account, the regular savings account, and 1950 from the tax-free one. And together they add to 2610, which is what it's supposed to equal, because that's what's on the right side. So since the left and right sides do work out to be the same thing in both equations, she does have $550 in the savings account and $650 in the tax-free savings account. Last example, number 4. Danny and Jane take their paddle boat up a river one sunny afternoon. They travel 12 kilometers in 6 hours. Okay, so they're going against the current. The return trip, going with the current now, only takes them 1.5 hours. Okay, because they're traveling downstream with the current instead. We're asked, what is the speed of the paddle boat in still water? So how fast can the paddle boat go if it weren't in any current? And what's the current speed, the speed of the river is flowing? And again, solve this using a system of linear equations. So this second last sentence here, what is the speed of the paddle boat and what's the current? That tells you what your let statement should be. Okay, so because those are the two things you're asked to find. How fast can the boat go? What's the speed of the current? So I'm going to let B represent the paddle boat speed, B for boat, and C represent the speed of the current. So those are my two variables. And in order to make this, now this one is a little different than the first three. There's no total amount equation. In order to get the equations, we're going to figure out in terms of these what the speed of the paddle boat is going upstream and downstream. And I'll explain about this a little bit. So this is kind of like if you've ever ridden a bicycle. If you're riding a bicycle with the wind allows you to go faster because it's pushing at your back, it's pushing you along. You can actually go faster than if there wasn't any wind. Because if you think of B as the bicycle speed and C as the wind current, if you're going with the wind, then the wind is added to your speed and you go faster. If you're going against, like going upstream, then it slows you down because you're going against the current. So the upstream speed is the boat speed minus whatever the current is. The downstream speed is the boat plus the current because it's helping you go faster. Now, we use this concept, and you might have seen this in a science class, distance is speed times time. We're going to use that to get two equations to solve to find out how fast the paddle boat can go in still water and what the current speed is for the river. So now distance equals speed times, so we're multiplying speed times time to get distance. Okay, speed times time equals distance. I'm actually going to get rid of that and write it in a different order. Instead, I'm going to write time multiplied by speed equals distance. It's the same thing, I just switched the order. Okay, it's still the same relationship. And that's just because it's a more convenient way to write the equations. So, when they went the 12 kilometers in 6 hours going against the current, the upstream one, the time was 6 hours. The speed would be the B minus C. So, okay, so that's the time. That's the 6 hours given here. The speed is the boat minus the current. That's the speed, and the distance was the 12 kilometers. So that's where those three things from. Three things came from. So this is the time, this is the speed, this is the distance. So that's what I mean by I'm using this to get an equation. For the downstream one, the time is the 1.5 hours. There it is right there. The speed will be the boat plus the current, and the distance is still 12 kilometers. They still went 12 kilometers back down the river. Now, those are the two equations. Those are two original equations. And when you have one of these, like with the current, with the wind questions, you can always simplify the equations to make them simpler to do substitution elimination, because these times will invariably always divide out. So what I'm going to do is I'm going to divide both sides by 6 here in the first one. So basically that's divided out. And so b minus c would equal 2, because 6 divided by 12 is 2. And the second one I'm going to divide out the 1.5. And so we would have b plus c on the left, and 12 divided by 1.5 is 8. So that's our system of equations, our simplified system of equations. When you do the check at the end, always go back to the original ones though. Maybe I'll get rid of my writings here. Now, solve by substitution. So it would be convenient to solve for b or c in either equation. It wouldn't matter, because we have all kinds of coefficients of 1 and negative 1. Okay, so I'm going to solve for b in this one. So what I'm going to do is I'm going to add c to both sides to isolate the b, because there's a c subtracted here, so adding c to both sides. So b would be 2 plus c. So now we're going to substitute that in this equation. So I'm going to write my b plus c equals 8 1 down. And this is the substituting that we're doing. So that's what b equals. So that is going to go right there. So instead of the b here, we're going to start with 2 plus c, and then plus the c equals 8. So just collecting like terms, c and c add to 2c, plus this 2 equals 8. So I'm trying to solve for c now. So I'll get rid of this 2 by subtracting 2 from both sides. So that's gone. 2c would equal 6, and then we would divide out the 2 to get c equals 3. So it looks like the current is 3 kilometers per hour. So now that I have c, I want to find b. So now we're going to find b. And you could take either equation. None of them would be more or less convenient than the others. They're all fairly straightforward because the coefficients are all 1 or negative 1. But I'm going to use the b minus c equals 2 1. So I'm going to put 3 and place a c here. So I want to solve for b. So the 3 is subtracted, so let's add 3 to both sides. So that adds to 0. So b would equal 5. 2 and 3 add to 5. So it looks like our solution is the boat speed is 5 kilometers per hour, and the current is flowing at 3 kilometers per hour. So that's the solution by substitution. By elimination, we could instead, and we don't need to do any multiplying here because all the coefficients are 1 or negative 1, so I'm just going to write the two equations down. And now I actually have two options here. I could subtract and eliminate the b's because they are exactly the same, or I could add and eliminate the c's because they're opposites. Okay, so I'm going to do the adding. I did subtracting in all the other ones, so I'm going to do adding here. So b and b add to 2b, and the c terms are opposites, so we add to 0, no c's at all, and 2 and 8 add to 10. Now I'm trying to solve for b here, so let's divide out the 2, and we will get b equals 5. So b is 5, so now if I was just doing elimination, I want to find what c is. So I could take one of my equations. I'm going to use the b minus c equals 2 1, and we'll put 5 right here. So trying to solve for c, so let's get rid of the 5 here. So let's subtract 5 from both sides. So you see that's 0, that's gone. Negative c would equal negative 3 here, and then we would divide out the negative 1 to solve for c. So we get c equals 3. So same solution we got over here. C is 3, B is 5. So the check, now go back to your original equations. This is the original equation. Don't check in this one or this one, okay? Because if you made an error from here to here or here to here and did everything else right but checked in these ones, you wouldn't find your mistake. Okay, so go back to your original equations to check. So in the original equations, 6 times b minus c is what's on the left side. So I'm putting 5 here and 3 here. So 5 minus 3 is 2 that we're multiplying by 6 to give us 12. Okay, so that was what was on the right side, so that's good. This is the left side for the second equation, the downstream one, 1.5 times b plus c. And again, 5 here and 3 here, that adds to 8. 8 times 1.5 is 12 again, okay, which is what's on the right side, so that's good. So since the left and right sides are both 12 in both of the equations, then the paddle boat speed is 5 kilometers per hour. That's what B represents according to our let statement. And the current of the river is 3 kilometers per hour. And that's the end of the tutorial.